Hey, welcome back, Logan. For today's installment of Math from Your Couch, we're going to be looking at multiplying rational expressions and dividing rational expressions. So multiplication of rational expressions is fairly straightforward. All you're going to do is multiply the tops together and then multiply the bottoms together. The way that this is going to look is you're going to have two fractions. Our first fraction a over b, our second fraction c over d, and we're just going to multiply the tops, a times c and b times d. Now, one note that I'd like you guys to keep in the back of your head is that while we're multiplying, you actually don't want to multiply until the very, very end. You're going to want to cancel your common factors as soon as possible. This is going to kind of save some time. It's like a shortcut almost. All right, so let's take a look at our first example. In our first example, we're just doing basic fractions. We have 5 over 4 and 7 over 9. So since it's multiplication, we can just multiply the tops together. So we're going to say 5 times 7. So we're going to write 5 times 7. And then we're going to say 4 times 9. So we multiply 4 times 9. Now at this stage, if you look at the 5, and if 5 is a factor or has a factor that is a factor of 4 or 9, you're going to go ahead and cancel them. But in this problem, you'll notice 5 and 7, they don't factor, and 4 and 9 have no factors in common with 5 and 7. So we're just going to multiply these two numbers together. 5 and 7 is 35, and 4 and 9 is 36. Now if you couldn't simplify here, you're not going to be able to simplify here, and this is your final answer for this problem. All right, now our second example, we're going to amp it up just a bit. We're going to make it look a little bit more like a rational expression, give it some variables. So our first one, in our second example, we have 4x over 3 times 6x to the power of 2 over 5. Now the way we want to approach this problem is, since it's multiplication, we're going to do exactly what it says. Multiply the tops together. So we're going to go 4x times the 6x to the power of 2 over, and we're going to multiply the bottoms together, 3 times 5. Now before I actually multiply the 3 and the 5 and then the 4x and the 6x to the power of 2, I'm going to focus on what it says over here. I am going to try to cancel, right? This is going to make it, it's going to give us a shortcut here. So when I look at this, you'll notice that the 4 has nothing in common with 3 or 5, but the 6, this guy right here, that 6 can actually simplify with the 3 that's right over here. So I'm going to go ahead and cancel that 3 with this 6, and the result is going to be a 2. So there's still a 2 left over where the 6 was. So now I can multiply the things together. So now that there's nothing else to cancel, we're going to go ahead and multiply them. So we're going to say 4x times 2x to the power of 2. So I'm going to go and write that out so you guys can see what it looks like. So we're going 4x times 2x to the power of 2 over, now this 3 is technically a 1 now, so I'm going to write 1 times 5. Now if you already knew that 1 times 5 is 5, you can go ahead and skip that step and just go straight to the 5 part. But then I just want to review this. 4x times 2x to the power of 2. 4 times 2 is 8. And when you have x times x to the power of 2, that gives us 3 x's, so x to the power of 3. And this is our simplified form for example number 2. Taking a look at example number 3, it's going to get much more complicated. So with example 3, what we now have is a bunch of polynomials. We approach the problem the same exact way. I'm going to color code this one a little bit more. We're going to multiply the tops together. So we're going to say x plus 3, and I'm actually going to write x plus 3 in parentheses. So we're going to go x plus 3 times the x plus 2. Anytime I deal with polynomials, I'll always use parentheses when I'm talking about multiplication of them. Over, and this is where it's going to get rather large. We're going to have x to the power of 2. Now that's a polynomial, so I'm going to put it in parentheses, x to the power of 2 plus 9x plus 14 times x minus 7, which is also a polynomial, a binomial, so we'll keep that in parentheses as well. Okay, so now the next thing you want to do is you want to simplify, but you'll notice that nothing looks exactly the same. But if you remember, polynomials, if you factor them, the chance that it looks the same as something else exists. So that's what we're going to do next. So I'm going to rewrite the problem. I'm just going to say x plus 3 is already factored. There's no GCF. There's no polynomial to factor out. X plus 2 is the same way. No GCF on that guy over there. Over. Now x to the power of 2 plus 9x plus 14, that's the one where you're going to want to set up your two binomials. So we're going to have two binomials for that. And then x squared is x times x. And now I need to run through the factors of 14. There are two sets of factors for 14, 14 and 1 and 7 and 2. Because it's a plus sign, we're going to say 7 and 2 works because 7 plus 2 is 9, and that's what the middle term is. So we're going to go with the 7 and the 2. Now to get, if that's a plus, we do have to add them. So to get a positive 9, the 7 has to be positive, which means the 2 will also be positive to get that addition. Now if you'll notice, there's a color that's still missing. That's because we forgot to bring down the x minus 7, so I'm going to bring that guy down as well. So now we have the x minus 7. All right, now you want to look to see if there's anything that we can cancel. You'll notice that in this problem, the x plus 2 here matches perfectly with the x plus 2 there, so they can cancel out because they're equivalent 1, so they're the same as 1. But nothing else can cancel. Now, what this means is that if you can't cancel it now, you will not be able to cancel it any other time in this problem. So we can now rewrite the problem after we multiply. On the top, it's just x plus 3. So we're going to write x plus 3. And on the bottom, we're going to FOIL this thing out. So we're going to multiply x times x, which is x to the power of 2, 7 times x, which is 7x, x times negative 7, which is negative 7x, and 7 times negative 7, which is negative 49. Now you'll notice that this 7x and the negative 7x canceled out, and if you already knew that this is going to be x to the power of 2 minus 49, by all means, just go straight to the x to the power of 2 minus 49. Now, if you remember what I said, you can't cancel anything up in the step above. That means nothing can cancel in the step below. This is our final answer. All right, moving on to the next topic. Now, the next topic is going to be about division. So now what we want to do is we want to divide rational expressions. Now, the book's term, or the book's definition of division, is that it's multiplication of the reciprocal. For me, one thing that I just remember is that it's KSF. This is something I learned from one of the middle school teachers, I think at Cesar Chavez. And what he teaches his class is that in division, it's called keep, switch, and flip. So what does this mean? If you're given a division problem, kind of like the one in blue, a over b divided by c over d, what you want to do is you want to apply this KSF, this keep, switch, flip idea. So that means we're going to keep this fraction. So we keep the first thing we see. And then we're going to switch the division sign to multiplication. And then we're going to flip the second fraction, and we get d over c. Now, this is exactly what we just did on the last 3 examples. This is just multiplication. So that means we're going to multiply the tops, a times d, and we're going to multiply the bottoms, b times c. All right, so this takes us to our last and final example, which is a division problem with polynomials and a little bit of monomials in there as well. All right, so first thing we're going to do is, since it's division, we're going to apply the keep, we're going to switch, and we're going to flip. So we're going to keep that first fraction, x to the power of 2 minus 9 over 4x to the power of 2 minus 12x. We're going to switch the division to a multiplication, and we're going to flip the second fraction, 6x to the power of 2 over x to the power of 2 plus 7x plus 12. Now from here, if you remember, this is multiplication. That means we're going to multiply the tops together. X to the power of 2 minus 9 is going to get multiplied by 6x to the power of 2. Now, since 6x to the power of 2 is not a polynomial, I'm not going to write it in parentheses, over, and then I have 2 polynomials that I still need to write. The 4x to the power of 2 minus 12x, and I'll put that in parentheses because it is a polynomial, and then finally the x to the power of 2 plus 7x plus 12. All right, now you'll notice that there's nothing that can cancel, obviously, so that usually indicates that we're going to want to start to factor these things out. So I'm going to start with the one in green. X squared minus 9 can simplify or factor to x plus 3 times x minus 3. That's what we call the difference of squares there. The 6x to the power of 2 is a monomial. I like to put the monomials in the front, so I'm just going to move the 6x to the power of 2 to the front of that fraction, the numerator. Next, we're going to divide, or write the division sign. And then we have to factor out what's in red. Now the thing in red, you'll notice they both can be divided by 4, and they both have an x in common. So what I'm going to do is I'm going to take out the GCF, the greatest common factor of 4x. That's going to give us x minus 3. And you'll notice that that's the same. If you were to distribute here, you'll get 4x to the power of 2 minus 12x. All right, finally, we're going to factor out this trinomial right here. We need to think of 2 numbers that multiply to 12. I'm thinking of 6, 2, 3, 4, and 12, 1. The one that actually ends up working is 3 and 4 because we want to get 7, and 3 plus 4 is 7. So we're going to go x plus 3 and x plus 4. All right, so now that we've factored, we can go through the problem and start canceling things out that are common. So we notice that the x minus 3's are the same, so we're going to go ahead and cancel those guys. We also notice that the x plus 3's are the same, so we can cancel those guys. And then that's it for our binomials. Now the binomials are really easy because they're going to look exactly the same. Where it gets tricky is the monomials, sorry. So on this one, you'll notice that this x right here can cancel with one of the x's here. So I'm going to cancel out the square and cancel out the x, because one of the x's on the bottom cancels with one of the x on the top. The next thing, you'll notice that 6 and 4 can both be divided by 2. That would give us 3 on the 6 and 2 on the 4. And then now we just want to go through the problem and just kind of clean it up. You'll notice on the top, now we have to be very careful, you'll notice on the top we still have a 3 and we still have that x right there. So there's nothing else, I'm just going to write 3x. So the numerator is 3x over, and then on the bottom we have a 2 and an x plus 4. So I'm going to write 2 times x plus 4. Now technically this is not completely simplified because you need to multiply this thing out. So we're going to multiply the 2 times x and the 2 times 4, which gives us 3x over 2x plus 8. And this is the simplified answer right there. All right, if you have any questions, please hit me up on email or send me a message on Google Classroom. And if you need a little bit extra help, you can also drop by office hours or class hours. All right, I'll talk to you guys later.